see the depth first search. Depth first search, as the name suggests, will go one depth at a time, and will go on the depth till we'll get the solution. So the depth first search always expand the deepest node in the current frontier of the search tree. Now here what will happen is we'll not go in one level at a time. We'll not go in one depth at a time. Instead, we'll explore one node and we'll go on exploring that node up to its last depth. We'll getting the solution, it is okay. Otherwise, we'll go again. So it is just like this. So let's assume that this is Bhubaneswar city. Let's assume that you are in the middle of that particular city. You are here in the middle of. Now you have to search your friend's room. What you have to search? Your friend's room. Now you don't know where it is. So what you do? I am talking about the depth first. So what we do is we'll go in one direction. And we'll explore all in that particular direction up to last border of the Bhubaneswar. We are not getting it, then we'll come back and we'll go for other depth. We'll come back and we'll go for other depth. We'll come back and we'll go for other depth. We'll come back and we'll go for other depth. Then we'll come back, we'll go for other depth. We'll come back, we'll go for other depth. So this is how the depth first search will work. Now in the same situation, let's say this is the city again, and you are in the middle of it. Now how the breadth first search work? So in that we'll go in, let's say 1 kilometer radius, all the houses will search. Then we'll go 2 kilometer radius, we'll search all the houses. Then we'll go 3 kilometer radius, we'll search all the houses. So you can see here in this particular scenario, we need more memory, or we have more area to cover. In that particular, we have to go in one direction. We have to we have the memory which is we required is very less. In one line we are going. Again we are backtracking. We are going another line. Again we are backtracking. We are going another line. But here it is like 1 kilometer radius will search, and then 2 kilometer radius will search. Will then 3 kilometer radius will search. In that way we'll search. This is the breadth first search. And this is the depth first search. So this is breadth first search, and this is depth first search. That is the difference between these two. So let's see the thing how it will be go. So let's say this is the root node. From the root node, we'll explore the child of the root node. So B and C has been explored. Now which one we have to explore? B has to be explored. Now B will explore D and E. Now D and E next will be in a previous algorithm. Next node to explore was C, as you can see here. Next node to explore was C after exploring B. But here what will happen is we are not exploring C. Instead, we are exploring the child of B, that is D. Now D after that will not explore its sibling. Instead, we'll explore its child. So as you can see, we have explored H, and then there is no node after H. Then we'll backtrack and we'll explore I. If I is not the solution, then we'll backtrack. which we haven't explored? E. So we'll explore E. After exploring E, we explore the child of E. One child has explored, then go for another child. Is not the solution, then go back and see this node, and this node we have to expand. In that way, we'll go on expanding. So in one depth, we'll go on till we'll reach the solution or till no node to explore. Then we'll backtrack again and we'll go to another path. So that is the meaning of depth first search. So the depth first search always expand the deepest node in the current frontier of the search tree. The progress of the search is illustrated in this particular figure. The search process immediately to the proceeds immediately to the depth level of the search tree, where the node has no successor. So till now, the node has no leaf node. It will be explored. As these nodes are expanded, they are dropped from the frontier so that the search backs up the next deepest node that still has to be expanded, explored successor. So all the time what we have to do is when we are expanding it, we have to remove it from the frontier list and we have to put into the explored list. For the state space for the branching factor P, the maximum depth M, the depth first search required to store how much? This is the storage capacity. Order of BM. B is the branching factor and M is the maximum depth or maximum path length. So what is the maximum path length? Based on that and the branching factor. Using the same assumption as for previous table and assumption that the node at the same depth as the goal node has no successor, will find out the depth first search, which required 156 kilobyte instead of 10 exabyte of a depth D16, a factor of 7 trillion times less space. So as you can see, with the depth 16, how much memory it is requiring in depth first search is 156 kilobyte in depth 16. Now, if you compare it with here, depth 16, how much time it is taking? 350 years. And how much memory it required? 10 exabyte. So 10 exabyte is required here with 16 depth. With 16 depth, 10 exabyte. But here it is required only 156 kilobyte. So you see the drastic change has been occurred when we choose a different searching algorithm. Okay. So if you are looking for your friend and you are in the station, railway station, and you will apply the depth first search, there is a possibility that you will get your friend as quick. But if you are applying the breadth first search, definitely it will take a lot of time. If the depth is more, means if it is in, let's say, 16 kilometer of radius, your friend is in 16 kilometer of radius, and you are applying the breadth first search. So you have to explore 1 kilometer area, then 2 kilometer area, then 3 kilometer area, then 4. In that way, you have to explore. But in the depth first search, what will happen is we'll go in one depth and we'll explore it. So there is a chance that when you are exploring the 16 kilometer in one depth, you might get your friend instead of exploring all the areas. So that is the difference between depth first search and breadth first search. So the time complexity of the, space complexity of the breadth first search will be denoted as order of branching factor into depth. But for the depth first search, the space complexity will be order of branching factor into M. M is nothing but the path length of the maximum leaf node in your state space. So this is your depth first search.